Suppose y varies directly with x. They're telling us that we're dealing with a direct variation situation, and so they want us to write a direct variation equation that relates x and y. Well, what we need to do at the start of this is we need to figure out what the k value is, because all of these equations will be written as y equals kx. So what is k? Well, rewriting this equation, and you should know this, by dividing both sides by x, we can find out that what k is by doing y divided by x. Okay, so in this particular case, we're doing -5 divided by 1/4. That's what k will be. Well, that's weird. -5 divided by 1/4. Instead of reducing a fraction, sometimes you need to make it greater by multiplying top and bottom so that you're dealing with whole numbers. Well, I can turn 1/4 into the whole number 1 by multiplying it by 4. And I multiply the top by 4 as well. And we will get -20 over 1, or just k is equal to -20. Yeah? So then if we wanted to write it in the form of y equals kx, using the actual k value, or the constant of variation for the equation that we're doing, we would use -20 for the k value. And so then we could write y equals -20x. Okay, so how do we graph that? Well, one way we could graph it is always put 0, 0 for direct variation equations. And we've already got one of the 2 points we need to graph a linear function. If it's linear, then you have 1 point and a second point, and you connect them. And then you're done. So what's the second point? Well, they gave us the information that x is 1/4. That x is 1/4, and y is -5. So we could graph 1/4 comma -5. I'm going to do something different, which is to say, now that we've got the equation, I'm going to just plug in a number for x, and I'm going to plug in 1. I'm going to say, okay, what if we said y equals -20 times 1? Then you would get y equals -20, meaning when x is 1, y is -20, or the point 1 comma -20 will be another point that we can graph, and then we will be able to connect them. So I'm going to label the graph right now. And let me just get all this out of here. I'm also going to plot the point 1 comma -20, which was we just found out by plugging in 1. So we can say, okay, I can go over to 1, down to -20. Remember, since we're going by 2's, going over to 1 is only going halfway up through that box, but then go all the way down. So we've got this point all the way down here. And then all I have to do is connect them. And I'm going to use my little line tool to connect them. And that's what the graph looks like, extremely steep. And negative, right? Because we had a negative equation. Oh, and so sorry, didn't mean to erase the equation itself, which was y equals -20x. Okay, so both of those parts together are the solution. Let's do it for number 33 now. So for number 33, we're going to do the same thing. We're going to find our k value by dividing y divided by x, or k is 7.2 divided by 1.2. And as you get better and better and more comfortable with math, you'll be able to know things like this is equal to 6. I just know that because I've familiarized myself with lots of numbers and calculations and all that. So the k value is 6. So we can then erase this and say, okay, k value 6. So then I can write the equation y equals 6 x. Okay, and again, how do we plot it? Well, we can always plot for direct variation 0, 0. And I'm going to let this scale be a scale of 1 right now. I'm going to say we can count over here 1, 2, 3, 4, 5. That's 10. That's 5. That's 10. And the reason that I want to do that with just a scale of 1 is because I can just plug in 1 for x, and let me write it up here. If I plug in 1 for x, y equals 6 parentheses 1, I get out y is 6 when x is 1, or 1 comma 6. Okay, so then I can plot that point as our second point. 1 comma 6, that's right up here. And if I make my line tool to connect these, then put little arrows, meaning they go on forever. I've graphed this, and so that's what the graph looks like. And let me get this out of here so you can just see the final result of what our equation is, which is y equals 6x. And box my answer, and we're done. Now you might notice, if you look at the answers on the answer page, that the graph for this one looks different than the graph that's on there. I'm curious if you can figure out why that is. Why does their line look different than my line? I'm going to leave that to you and have you ask me because, well, and I'll just give you a little hint. You're going to want to look at what numbers they used for here and what numbers they used for here. How does what they used as the scale differ from what I used as the scale, and how does that affect what the graph looks like? A good little exercise for you to think about, because if you can puzzle that out, or you can talk it out with somebody else, then you can understand why graphs might represent the same data but look slightly differently. So yeah, talk to me about that if you can't get an answer for it, or you're not really sure what the answer is and you have nobody else to talk to about it. But definitely worth understanding. So don't let it go by. If you don't get it and you don't know the answer, definitely come to me or speak with someone else. Okay, good luck.